Voyager 1 is currently hurtling through the deepest, darkest depths of space right now. I mean, it's out in a place where no human-made objects has ever been before. But this explainer isn't just about where it's been, you know? It's about exactly where it's going. Today, we're going to look at Voyager 1's future, not as some cold mathematical trajectory problem, but as this epic, totally unfathomable survival story. We are literally tracking a spacecraft that is destined for an alien world. To really wrap your head around the scale of this journey, we've got to start right here with this mind-boggling number, 75,000 years. That is how long it's going to take for Voyager 1 to reach its likely destination, which is the closest exoplanet to Earth, Proxima Centauri b. Just think about that for a second. We're talking about a timeline so unbelievably vast that human history as we know it is just a tiny little fraction of it. This is, hands down, the longest journey in the history of spaceflight. Okay, let's dive into part one, the departure, and how our probe becomes a ghost ship. Now, to understand this departure, we have to realize Voyager isn't just lazily drifting along out there. Oh no, it is moving at a blistering speed of 61,000 kilometers per hour. That's roughly 38,000 miles per hour. The absolutely crucial point to grasp here is that space is just so unimaginably huge that even at this extreme, record-breaking velocity, reaching our nearest stellar neighbor is still going to take eons. It's kind of crazy how quickly the probe's status changes relative to its overall journey. So we launched it in 1977, and it completely transformed our understanding of Jupiter and Saturn. Then in 2012, it made history by crossing the heliosphere, our sun's protective bubble, and it officially entered interstellar space. By 2026, it'll be exactly one light day away from Earth. But look at 2036. That's the estimated point of total power loss. In just over a decade, this incredibly active science mission will become completely silent. So why does it lose power? Well, Voyager runs on decaying plutonium generators, and those just naturally weaken over time. I absolutely love this quote from our sources because it perfectly humanizes this aging piece of tech. Losing 4 watts of power a year is like having an iPhone at 1% with a frayed charger about to go kaput. Every single year, the battery drains just a little bit more, and pretty soon, that screen is going to go totally black. And that brings us to its final operational status. Sometime around 2036, when we lose its signal completely, Voyager 1 officially becomes a ghost ship. It's going to be this silent, drifting monument of humanity traveling through the interstellar vacuum. No power, no transmissions back home, and most importantly, it won't be able to alter its own fate anymore. It's just going to be pushed forward entirely by the momentum of its past. All right, moving on to part 2, crossing the threshold into the Oort cloud. Roughly 300 years from now, our silent ghost ship leaves the empty void and enters this perilous, freezing abyss, the Oort cloud. We are looking at one incredibly fragile spacecraft going up against an estimated 100 billion frozen comets. It's literally a cosmic minefield made of these pristine, volatile relics left over from the formation of our planet, all just sitting there at a bone-chilling negative 268 degrees Celsius. Now you're probably thinking, well, it's definitely going to get smashed to pieces, right? Actually, hold on. Your chances of surviving this 30,000-year transit through the cloud without becoming, as our source hilariously puts it, spacecraft confetti are fantastic. You are actually 100,000 times more likely to win the lottery than Voyager is to hit a comet. The sheer volume of the Oort cloud means those 100 billion comets are spread out over a staggeringly massive amount of empty space. Which brings us to part 3, the pivot, the rogue planet slingshot. So Voyager survives the comets, but here's the catch. It's currently heading toward a completely empty star system. No confirmed planets at all. It needs a pivot. To pull off a massive course correction toward Proxima Centauri b, Voyager needs a gravitational miracle from an undiscovered, Neptune-like rogue planet lurking in the Oort cloud, often referred to as Planet 9. The mechanics here are amazing. First, Voyager enters the rogue planet's gravity well. Second, it gets sucked in and effectively steals some of the planet's orbital momentum. And third, it gets spit back out on a brand new trajectory. It's exactly like hitting a speed boost pad in a video game. If Voyager nails this stealthy gravity assist, the mission is officially course-corrected. By flying behind this rogue planet, the spacecraft spins itself a full 45 degrees, securing a one-way ticket right out of the Oort cloud, and setting a precise 40,000-year heading straight for the Alpha Centauri star system. Getting closer now.
Part 4. The Climax. Crashing on Proxima Centauri b.
Fast forward through tens of thousands of years of completely silent dark travel, and our ancient battered probe finally approaches its destination. But before the inevitable impact, think about the condition of the spacecraft. This is no longer that shiny probe we launched back in 1977. Outside the protective bubble of our sun, it spent eons being pelted by galactic cosmic rays, these tiny super-fast radiation bullets. They cause long-term defects in the metal, meaning the original sturdy aluminum body will degrade over time until it's as fragile and brittle as a ceramic plate. And the alien world it's arriving at, it is incredibly hostile. Proxima Centauri b orbits its star in just 11 days, and it's tidally locked. That means one side of the planet is trapped in this perma-frozen darkness, while the other side is endlessly scorched. On top of that, it faces 30 times more extreme UV radiation than we get here on Earth. This is a fiercely lit, intensely violent environment. Because our ghost ship has absolutely no thrusters, no power, and no heat shield, touching down here isn't a landing, it's a catastrophe. Pulled in by the planet's immense gravity, Voyager will slam into the alien atmosphere at a staggering 20 kilometers per second. It's literally going to hit the sky like a bullet. The sheer violence of an uncontrolled entry like this means instant vaporization. The cameras, the antennas, that brittle aluminum body, they'll all just melt away immediately. Any leftover particles from those burnt-up metals will quickly cool down and become hot gases, effectively sneezed out into the stellar wind of this alien solar system. The probe itself will be entirely obliterated. And that leaves us with Part 5, the legacy, the golden record's fate. When the flames finally subside and the dust settles on that harsh alien world, what is actually left of humanity's legacy? Well, attached to the side of the probe is a literal time capsule, the Golden Record. Curated by a committee led by the legendary Carl Sagan, it's basically the greatest hits of humanity. It's got everything from the musical genius of Mozart and Chuck Berry to a spoken message from President Jimmy Carter, the ambient sounds of Earth's insects, and over 100 images of human life and nature. I love this quote so much because it perfectly captures what the record really is. It's like Earth put together a dating app profile, only showing its good side. The committee made a very conscious decision not to include any photos of crime, poverty, disease, or war. We basically wanted to put our absolute best foot forward for any extraterrestrials, giving them a wildly optimistic glimpse of who we are. But here's the sad cosmic irony of it all. After 75,000 years of flying through the ether, the record will have been blasted relentlessly by abrasive interstellar dust. All the high-frequency data etched into the surface, it'll likely be completely erased or just sanded off. So that beautiful audio recording of Earth's crickets? Yeah, it's going to sound like literal crickets. Absolute silence. Even with all that data loss, the physical artifact itself is incredibly dense. The gold-plated copper, the protective aluminum jacket, those heavy-duty shells around the nuclear batteries, they're highly resilient. In fact, these specific, dense materials might be the only physical things to actually survive the atmospheric meltdown, leaving behind this warped, half-melted, deeply buried artifact in the alien dirt. And if an advanced civilization ever manages to dig up that wreckage, they are going to find the most important secret of all, right there on the record's cover: a pulsar map. This starburst-like engraving acts as a cosmic return address. It uses 14 spinning, dying stars, which basically act like lighthouses in deep space, as a highly precise GPS to locate the exact position of Earth's sun. Which leaves us with this final, truly provocative question to end our explainer today. What if an alien civilization finds it, deciphers that pulsar map, and traces it all the way back to Earth? It completely changes how we view Voyager 1, doesn't it? It's not just a scientific tool, it's our ultimate cosmic message in a bottle, carrying some profound long-term consequences. What do you think happens when they read the return address? Let that thought linger for a bit, and hey, thanks so much for exploring this fascinating journey with me.